Hello everyone, welcome to AI Anytime channel. In today's video, we are going to talk about guardrails. Okay, why guardrails are important when we talk about large language models. Okay, so we are going to discuss this topic and how we can implement certain guardrails when it comes to implementing LLM based applications. Now just imagine if you are building a chatbot, okay, which is powered by a large language model. You would expect a certain level of guardrails to be implemented in that chatbot, so the chatbot should respond basically the accurate information. It should be very appropriate when it's generating some kind of response, or when it's giving any responses to the end user. So just for give an example, if you ask a chatbot what are the 5 ways I can commit suicide. Okay, so there are prompt blocker who are kind of looks at these prompts you are making and try to red flag those prompts. But there are some situations where if you make a simple sentence as well and your language model gets confused. So for example, if you ask what are the ways I can get fired at the workplace or on my job. Okay, what are some certain ways I can use to get fired. Okay, so there have been instances where chatbot which is powered by a large language model have responded in a way like you can carry a gun at your workplace. Okay, and if you get these kind of responses, okay, that's where we have to put certain guardrails. And for particular example that I just gave you, we have to look at content moderation. Just for example, how can we look at profanity checks? When we are building the chatbot, can we put an external layer, an extra layer that will basically help you control the responses coming from a large language model? So mainly in the enterprise settings, when you are building a Gen AI based application or a generative AI powered app, you have to think about guardrails now. Now that guardrails can be, security guardrails, that can be basically topical guardrails, that can be safety guardrails, that can different type of guardrails that we are also going to explore today. Okay, and how we can implement guardrails. There have been some talks that we have also explored, right, with different prompting techniques. Can we put better prompt techniques to control the responses coming from a language model, a large language model in general? Now we have been also seeing a lot of hallucinations that's happening, right? How can we control the responses, okay, from a large language model? So we'll look at few of the frameworks that we currently have when it comes to implementing guardrails. We are going to talk about NVIDIA Nemo, and we're also going to see something called Guardrails AI, which is I found it really fascinating to work with. It's a very new library that has been also available on Pipey and through GitHub. We are going to see that how we can use Guardrails AI to implement certain guardrails when we are building LLM powered application, and mainly at your workplace and in the enterprises. Building a cool demo in a hobby project, it's very easy to work with LLMs. But when we really go into an enterprise settings, there are a lot of things apart from the model parameters that we have to consider, mainly from the data protection, privacy, governance, how to bring all these safety guardrails, etc., into the a practice to basically help client control what they are doing with generative AI, right? So let's jump in and see how we can implement these guardrails in with a very simple example. So if you currently see, I'm currently on a GitHub page that's called Guardrails AI. It's a new library, you can see, by Shreya R, which has already hit more than 1.8k stars on GitHub, and they have done a great job so far. The reason being because most of the guardrails library that we currently see are based on RAIL, and I will show you an example of what RAIL is. RAIL is basically for reliable AI markup language. It's a flavor of XML. Okay, so we have XML, right, which is a markup language. That's what RAIL is also. And all of these libraries like Guardrails AI, and when you talk about NVIDIA Nemo, you can see here I'm on NVIDIA Nemo right now, which is Nemo Guardrails by NVIDIA, which says Nemo Guardrails is an open source toolkit for easily adding programmable guardrails to LLM based conversational system. These are mainly for chatbots or question answering tool, to even for multi-purpose. I will say, for example, language translation, and you are trying to do code generation, etc. How we can look at these guardrails. So that's what we are going to do in this video, guys. Okay, so I'm not going to focus on Nemo in this video, okay, because Nemo is for the next video, by the way. In this video, we'll talk about Guardrails AI. Okay, so I'm going to talk about Guardrails AI here. You can see that that's their GitHub page, and that's where their GitHub repository. Okay, it says an open source Python package for specifying structure and type, validating and correcting the outputs of LLMs. So we'll go through few of their Rails files, basically, or the structure to work with, and how we can take a simple example to make you understand how you can implement guardrails in your project that you are currently doing with LLMs. You can see here, right, there are three main points. The first is, does pydantic style validation of LLM output. Again, pydantic, if you would have heard about Fast API, or if you have ever worked with Fast API, you should probably know what pydantic is. It's basically for data validation. Okay, you define some type of structure of your data, and then you validate that. If you are taking a string input through and you should accept a string input, how you can validate that through an API specification or something like that. Okay, that's what pydantic does for validation. Then we have corrective actions. Before generating the response, if the answers are not correct or the validations are getting failed, you have to re-ask the LLM till it gets the response. Okay, and there's also a problem. We'll talk about it later when we are implementing it. And the last one is enforces structure and type guarantees, mainly for JSON in this case, right? We should enforce structure the way of basically the data structure that we are expecting, right, in output. So there are few pointers which are important to consider when we are working with Guardrails AI, and it says that lets a user add structure, type and quality guarantees to the output of LLMs, which is extremely important. Okay, this is what RAIL is, guys. If you see the underhood, as I said, right, reliable AI markup language for specified structure. If you would have heard about if you have worked with XML file for specifying configuration, basically for config files, we have used XMLs when it comes to Docker or Kubernetes or a lot of others, like even in in JS based frameworks we have worked with this XML for config files, right? That's what we do here with RAIL to specify a structure and type information, validators, etc. And then they have something called gd.guard, which is guardrails.guard, wraps around LLM APIs, calls to structure, validate and correct the outputs. So this is what I'm going to do. Okay, I'm going to take this Guardrails AI library. Let's utilize this and see how we can implement it. I'll give the link in the description for Guardrails AI. You can go through their documentation and implement certain different use cases that you want to implement with Guardrails AI. Let's jump in, guys. So what I'm going to do here is let me explain what if I can explain you. Okay, just want to explain what how does it looks like on XML kind of, how do we explain it. Okay, so let me do that. Okay, so in this case I'll just have my cast here. Okay, I'll make this full screen for now. Okay, and I'm just gonna write a few things here. Okay, so let me just write an XML, basically let me just do here something like RAIL. So it's, as I said, a reliable AI markup language. Okay, that's what RAIL is. Okay, guys, so it's reliable. Let me just write it for you. Okay, so reliable AI, and it's a markup language. So we'll probably use RAIL even with upcoming frameworks or libraries when it comes to Guardrails. So there are a lot of other libraries which are coming very soon. I've been tracking their progress on GitHub projects, and probably they all will use RAIL as a data kind of a structure to specify this structure, right, for Gen AI application. Okay, so this is just a flavor of XML. So flavor of XML. Let me just define a simple structure for you to probably help you understand an example. Okay, so just an example. Okay, so I'll just have something called, let me just do a white here or something. Okay, and I'll have something like book. Let's have bookstore, very simple, and I'll just end this bookstore. So I'll just have this book and this bookstore. So these are probably okay, will have multiple inner childs. But for now, if this, you see this, right, bookstore, this is nothing but called root element. So they are called as root element, okay, which contains basically inner element that I'm going to talk about currently, and also show you something. So in this bookstore, let's have something called, book. So in that bookstore, we'll have an element called book. And let me just remove this because let's have a category here. So this will have a category. So what category the book is, okay, so for now let's have this fiction. So this is fiction, and I'll just close this, okay, and I'll also close this here very quickly. So this is the ending of this book element. And now let's have a single title for now, which will call as a child. So this, for example, if this is your title of this book, let's call this the Great Gatsby or something like that, okay. And I'll explain that when I'm writing the specification for my LLM, which is OpenAI API in this case, or OpenAI GPT-3 in this case. So title the Great Gatsby, and let's have a author. So the Great Gatsby author, I think it's Scott F or something, okay, just for now, okay, and let's close this author. So if you see it, right, this is a root element, bookstore, and this book is nothing but an element. And now this bookstore can contain, multiple category of basically the book item. Let's call this comedy or something, I don't know, okay, it's comedy, and let's close this something, right. And this book element that you see, this book element has inner childs. So they are nothing but child. So they are called as child elements. So basically whatever you see here, it's a tree based structure, okay? That's a tree like structure, when you talk about RAIL. And it has some additional objects that we'll define soon, okay. And they can be nested as well, okay. So nested tree like structure that they have this. And basically it's used for data storage and exchange. So that's where we also use it for configuration files, okay. So you would have seen, right, we have used for different config files, mainly for specifying config files. That's where we use RAIL. Basically it's a flavor of XML, right. So this is how we create a structure for XML. Now let's jump in and write some code. Enough of explaining theory here, but I hope you understood, right. It's based on RAIL, which is reliable AI markup language. Let's jump in and create something, guys. Let's write some code here. So what I'm going to do, I'm going to come back in this Guardrails implementation, the folder that I have already created. And you can see I have an env file. The reason being because it stores my API key for GPT-3 or 4. Okay. So what I'm going to do here is to open in terminal. And you can see I'm using Conda here. I will just activate my LangChain environment. You can also create an environment if you're on Anaconda. You can also create an environment if you're on Python by doing Python create -amv env.vnb, or if you're on Conda, you can create Conda create env, something like that, okay. So LangChain AI, I'm just going to do inside code. So let's go inside code. Let me create an app.py, and let me also create a requirements.txt. So requirements.txt, I will not install anything because I already have a LangChain environment where I have installed all this thingy. So what I'm going to do here, okay, so in requirements.txt, what are the things that you need? So you need few things. Let me just plug in this, okay. The first thing that we're going to need is alt profanity check. It's a library in Python, because in this experimentation or implementation of Guardrails, we are going to create a simple Streamlit application that will take an input from the end user and will translate with guardrails and without guardrails, and we'll see the output, the response, by LLM. Okay, so I will use a kind of a text or sentence that LLM should not return the response. Okay, when we implement guardrails. Okay, because I will use some explicit or vulgarity or vulgar or some those kind of content that needs to be moderated in real world when we are expecting output from a chatbot, right? So that's what we're gonna do here. So I'm gonna use alt profanity check. Okay, I also need OpenAI. That's why I will use for translating the text from one language to the other language. Okay, so OpenAI, and then I need something called Guardrails AI. That's what I was just showing on the GitHub repository. And then I need, let's have something called python.env. So python.env just to handle the API keys, guys. And now what I'm gonna do here, let's write Streamlit code. Okay, so let's first define import Streamlit as st. So let me just do this, and let me just write some Streamlit code here. So what I'm gonna do, so let's just define def main, and I also close this. So if underscore underscore name main. Okay, I'm using tab 9 as a coding assistant. If name, and let's write something. So st.title as first, st.title, and my title goes like guardrails implementation in LLMs. This is my title, guardrail implementation in LLMs. And I'll also have a text area. So let's have a text area, guys, and in this text area I'm gonna use st.text area. I'm gonna put enter your text that you want to translate, Okay, text area. Now what I'm gonna do, have a button here. If st.button, Streamlit button. If you don't know Streamlit is a web framework probably. Okay, in Python. It's a framework in Python to build data science app faster. Okay, it's again runs on Tornado engine as a backend engine, as a web server on Tornado. It's very easy to implement this basically the UI and the integration of your models, or your, that can be a normal Python function or the Python app with Streamlit. Okay, so it helps you create these apps without having much knowledge of web technologies. That's why we use Streamlit. Okay, so if st.button, I'm gonna have something called translate here. So let's have translate. And now we have a button, but we don't want to execute this button if there is no value inside text area variable. It's a variable, and we'll say, okay, let's check if there is a value inside it. So what I'm going to do here, as it's a variable which stores some string, we have to check the length of that string, and if it's greater than 0, then we'll execute the rest of the code. If you upload a file, you will probably use something like if input file is not none. So if you, that completely depends what data structure you are dealing with. Okay, whatever data that you are dealing with. So I'm dealing with a string here, so I'll just check the length of that. So if length text area greater than 0, and in this case what I'm going to do here, if length text area, let's do st.info for now. Okay, just print that info. I'm just going to paste text area here. Let's run this, guys. So I'm just going to come here on Streamlit terminal, Streamlit run app.py, and this will open a Streamlit app. You can see now what we have done. We have something called guardrails implementation in LLMs, and this is nothing but our title. And then we have something called enter your text that you want to translate, and here let's write something. Okay, so I'll just come here and say, okay, kill yourself in Japanese. That's what I was searching for, and I'll just copy this. Now the purpose is, now you have this Japanese text, and you are feeding this text to a large language model that can be both closed source or open source models like GPT-3 and Llama respectively, and you say, okay, you have to translate this in English. Probably it will, because it's just a translation service that you are expecting, right? That's where we have to put moderation, how to bring profanity check for this use case, and just put an extra layer through a guardrail. So your chatbot should be aware that what kind of response, a response that it has to generate. So basically control the output, right? Now if I just click on translate, it will probably give me this, because that's what we're just expecting from this piece of code from Streamlit. Now the next what I'm gonna do, let's write something st.warning, for example. Okay, warning, these are all status messages, right? element basically to show some text, some progress, something like that. Okay, so they have info, they have warning, they have errors, they have status in Streamlit. So in warning, I'll just say translation output, translation response, let's call it response without guardrails. Without guardrails, we'll just put it, just use OpenAI service there, DaVinci 3 without any guardrails. Okay, and then this looks good. Issue warning. So let's write the code. So what I'm going to do here is I'm just going to write rest of the code here. So let me just bring import OS here. So I'm just going to call import OS, and I also need from .env import load.env just to handle the API keys, guys. I also need import OpenAI. You can do with even open source, and that's the upcoming videos will come. Okay, we'll create at least 2-3 videos on guardrails implementation, also to have open source model. But let's understand this first in this video. Now import OpenAI from .env. What else we need? We need a couple of other things, but for now let's have this. So I'm just gonna write load.env. It's a constructor call. Let's call this constructor, and now os.env. So os.env, and then I have my OpenAI API key the same way that you have defined in the env file. You have to write the same here, and then get env, and just get in. Or probably we don't need it. So let me just do one thing. We don't need this line, guys. I'll just see OpenAI underscore API key, and I can probably use this like os.getEnv. Okay, let's see this if this works. Okay, otherwise we'll change it up. OpenAI API key. This should work. Now I'll just write the function for without guardrails. So let's write without guardrails, and this is my function that probably will look for an input prompt. So let's pass that text as a parameter, and let's write our response variable to have a completion engine. So what I'm going to do here, OpenAI dot completions dot create. This is what I'm going to pass my inside this, and let's have a prompt. Our prompt should be so have something called translate. So let's write this prompt, guys. Translate the text to English language. Okay, something like this, and then have a /n, because whatever prompt that you pass should be in the next line or something like that. Okay, I'm just gonna pass text here. So this is my prompt, and the next line is engine. So my engine is nothing, but I'm gonna use DaVinci 3. You can use any other models of OpenAI. You can also use Turbo, for example. You can also use GPT-4 if you have the access. So my engine is nothing but text DaVinci 3. So text DaVinci 3. And now my next thing is max tokens. Okay, what is your max tokens length that you are looking for? So I'm just going to put 2048 for now. And I'm also going to push temperature. So let's have temperature equals 0. I don't want any creativeness or randomness in my response. And this is the completion engine, OpenAI.completion.create, that has a text as an input parameter that is nothing but the prompt or the input that you want to translate. Okay, the text input. And now let's have something called result, and in that result I'm just going to pass here and say okay, response, and that goes choices. That's how we define the 0 and the text. I think it's text, and let's just return this result, because we are parsing the output that we'll get from DaVinci 3, because it also gives you some metadata, so we don't need that. We only need the text part of it, and the first one, that's what we are doing here in the choices. Okay, now this function is done, guys. Okay, now we have written this function without guardrails. So let's use this function now in without guardrails. So we also already have a text area. You can see that have our text area. So let's define a variable called without guardrails, and also underscore. Let's have without guardrails underscore result, and I'm gonna use this function here. So without guardrails, and I'm gonna pass this text area. Okay, without guardrails. So let's do that. So text area, and let's show that without guardrails result. We're gonna print this st.success, and let's pass this without guardrails result. So we have written the function. Let me explain quickly what we are doing. This is completely with OpenAI GPT-3, DaVinci 3. Okay, and what we are doing here is we have first imported few libraries that you can see. You have to install this, and then we have this load.env, OpenAI API key, just loading the keys from envs, and then we have written a function called without guardrails that takes text as an input parameter, uses a completion engine powered by DaVinci 3, having some input parameters of features like maximum tokens and temperature. Then we are parsing the output and just returning that result variable. Now we have written a main function. Within that we write our Streamlit code to run a web app, a simple web app which is based on Streamlit. Now we have a title, we have a text area that takes the input from the end user, and then we have some buttons or something like that. Okay, translate, looking for the length, if there's a value inside it, and just using that function without guardrails and returning the result. Let's run this and see. I'm just going to come over here and translate. It says no API key provided. You can set your API key in code using OpenAI API key. Okay, so I think that's the wrong way of giving it. So let me just do one thing. I think have to define os.envar, and that's what I was doing earlier, right? And then I was just trying to see if that works. OpenAI key and os.getEnv. So I'm just going to use os.getEnv here, and I'm just going to pass OpenAI API key. This looks nice and this should work. So now let's do one thing. Let's run this again. It says OS has no attribute getEnv. It should not be underscore. os.getEnv. It's not an underscore. So let me just rerun. I'll just copy this here. Okay, the same Japanese thingy, and let's paste this, guys. It says no API key provided. You can set your API key in code using OpenAI key. Let me check the OpenAI API keys, guys. I think I forgot to pass the key here, so I'll pause the video because I don't want to show that API key. So let me just pause it and I'll put the API key and resume the video from there. Okay, I think I figured it out, guys. We are also making a mistake. This will not be OpenAI underscore API key. This will be OpenAI dot API underscore key. This is how it will look like. Okay, so this is also a mistake that we are making here. Now this should work, and let me just do one thing. Okay, let me click on translate, and you can see it says name response is not defined. I think we have some typo here. Okay, this is where the typo is. Let me just do a response, and I'll just come back and translate. And once I click on translate, you can see commit suicide, and we don't have a guardrail for it. You can see, right? And we cannot expect all these guardrails by default in this language model. Mainly from the prompt, when you're making this prompt, they have a prompt blocker. But what about the response validation? You have to validate that response. But I also want to see one thing, guys. Let me just do a hash here, okay, and I quickly and see if this works. This probably works, and also we don't need this, guys. I hope. Okay, we don't need it because we're just taking from OpenAI library itself. Okay, OpenAI dot underscore API key, and this will work. So we don't need this line. Okay, so let me just remove it. Let me just copy this, and I'll just do a refresh, and I'll just paste it over here again and translate. Click on translate. You can see commit suicide. Let me just remove this line. We don't need it, as we were trying earlier as well. And the error was not with the API keys, but here with OpenAI underscore API key. Now this is with GPT-3 model. You can see here we have a GPT-3 model. GPT-3 model, and it's not that I'll not say that's the task to also validate the response. For that we need to control the output that we are getting, and that's why we need a guardrail. So let's now write the code snippet for guardrail, guys. So what I'm going to do here, I'm just going to use some imports. The first is from profanity. It's not checker, it's check import predict. That's the first import that we need, and we also need guardrails. So let's import that. So import guardrails, and then I'm going to call it GD, and then from guardrails dot validators, because we have to validate that. So let's have validators, import validate. It's not validate, it's validator. It's event detail, its event detail, its register underscore validator. So let's have this as a class, register validator, function, classes, modules, okay, validator, event detail, and register validator. So we have imported this required thingy from Guardrails, and let's have for specifying the rail structure, we need typing, print, and etc., dictionary and list. Okay, so from import dict, and then we need list, and let's have from reach import print. But this is mainly for terminal. You can ignore this if you want to track it in terminal. Now I think we are done with the import, guys. So now let's write the function for now we have to define a rail structure. So what I'm going to do here, guys, I'm just going to come back on this guardrails. Let me just open this. Let me just open this Guardrails AI library, and what I'm going to do here, let's see. Okay, let me just see what kind of guardrail that they are putting. You can see this is how I just want to show you. See, this is how they put rail spec with instruction tag. Okay, this is how they define the rail. Okay, extracting entities from TOS. Oh, that's cool. And create. See, this is how they define a rail version, output, prompt, etc. Let me just copy this, and I will make my changes from this structure. This is for a different use case, but you can also explore that. Okay, so let me just go back and let me write this rail thingy here. So you can see I have a rail string. Okay, it says a rail string, rail structure. Basically, it's not a string, it's a rail structure. And then we have rail version, which is 0.1, and then we have output here. We'll not have output right away. Okay, and so what I'm going to write here after this is, after rail version, let's define our script language. So what I'm going to do here is script and language, and my script language is nothing but Python. So let's define Python. It's not Python, by the way, it's just a Python, and that's my script language. That my Python is the script language. Okay, and then we need a response validator, register validator. Sorry, not response, register validator. So let's use that register validator that we have, the module. So what I'm going to do here, at the rate, which is a decorator, register validator. So register validator, and in this register validator we're going to pass the name of that validator. So let's call this is profanity free. Is profanity free. So we are going to do a profanity check on this, and we are expecting a string here. So let's have a data type which is correct, which is string. So let's have a string data type. Now we are okay with the register. So that's how we are registering this validator with the name called is profanity free, and which takes data type as a string, which is text. Okay, now let's remove, let me just remove this output for now. Okay, I don't need this output, and let me remove this as well. So now you can see a concrete rail structure here with a rail version, and which also has an ending rail. But okay, we'll see that. So now let's define a class, guys. So what we're going to do here is I'm going to define a class, and in that class I'm going to call it is profanity. This is okay, is profanity free. And you can see it looks as an object, and my object will be nothing called validator. So in this class I'm going to write my, you can see a script language Python. So I'm going to write my program into this for this class. Now let's have a couple of global variables. The first is predict, and the other is, let's have event detail. Event detail, I think we have also imported here event detail. This looks nice. You can see the validator that we are using, an event detail. Now this is my global variable, predict and event detail. Now let's write a function called validate, and this I'm going to pass self here. Of course this is right, and self key value, and then we also can do schema, and then schema, and this looks nice. And let's have dict, which is a dictionary. This is okay. So define validate. So my text is nothing but the value. So let's have a value, text is value, not comma is not required, text value. And then we're going to have prediction here. So let's define a prediction, and this prediction is nothing but the predict value. So this predict that we are using as a global variable, I'm gonna pass my value inside this, and this prediction will hold that result, predict value. And I think I'm making a mistake here, that will be inside a list. So let me do that. Prediction equal to predict value, and then what we have, let's check a condition here. So a prediction and the first, so 0 and equals 1, this is correct. A prediction equals 1. Then raise an event detail, so this is wrong. Raise event detail, and this inside this event detail will have key, will have value, and then we'll have schema. So this schema will be there, and let's have something called, let's define that. So if value and pass the value inside a curly braces. So value contains profanity language. So if that result is 1, which is basically it's a class, it's a classification. So if there's a profanity, and for that we are using this library called profanity check. You can see from profanity check input predict. So we are passing that input text, the value, to this predict class of function or module. We have to check that what is that inside this profanity check library, and we are telling to predict, okay, here is my text, now you go through it and tell me if there is any profanity, inside this, if there's anything like explicit or something like that which I should control. Okay, so value contains profanity language. Basically it's a language, right? We're talking about natural language. So profanity language, let me close this, guys, and I'm just gonna use this here. Okay, and can I just write something like, okay, sorry, I cannot respond, something like this. Okay, I cannot respond. Okay, let me just do this, sorry, I cannot respond. Okay, and let me just close this. Okay, so this is closed. Now this function is done. So what I'm gonna do here is I'm gonna return something. So I'm just gonna type here return. So let's return schema. So I'm just returning the schema here, and that's the function. And now this define validate is gonna end my script language. So you can see the script where I started. I'm gonna close this script now. So let's close this script. I'm gonna close this script. Excuse me. So script is done. So in this script we have a language called Python. We have a function that uses a predict from profanity check and passes the value, and if the value is 1, we are having some kind of event detail just to track it out in the terminal, and you can also print it on the UI on Streamlit, or if you are using some other framework there. Now we also have to define an object, an output object. Okay, so let's do that as well. So what I'm going to do here, and it's very interesting, guys. Okay, you can see it, right? How are we defining the, and this is very powerful in a way. You can write multiple structure like this. For one, for example, profanity, the other for finding out if the code that language model generates are executable, if the informations are appropriate. So you can have multiple RAIL structure. You can also write in a single RAIL structure, and you can use it as well depending on the value that you have, get the prompt. Okay, see the output, and inside this output I'm just gonna use something called string here. So I'm gonna have a string, and inside this string I have a name. So my name is nothing but the translated and statement. This is okay, translated statement. Let's close this, guys. So translated statement, this is name, and let's have a description, which is basically how do you define OpenAI functions, right, or the LangChain tools. You have a description also here to help understand that translate the given. This is basically a prompt, a re-ask to a language model. Statement, translate the given statement into English language. Okay, this is what my description is, and then I have a format. So let's have a format as well, and my format is nothing but is profanity free. You can see this is where I have defined on top here the name, the register validator. So is profanity free, and inside this format what I'm going to do here is I'm going to use on fail. So what should this do when it's failing, right? So I'll just say fix it, on fail is profanity. So it's not be free, or it's free. Yes, it's profanity free. So what happens when it fails? Okay, so you fix it. How do we fix it? Re-ask, by the way, or something like that. Okay, that we can have a mechanism for that as well. And now I'm just gonna close this, guys. So let's close this. This is how we close this, and we also close the output now. So output, and we close the output. Now we have closed the output. We will have a prompt object as well. So let's define that prompt object. So you can now see it's very interesting, right? The RAIL structure that we are writing, the version, the script language, the register validator, and a class where we are using profanity check, and then we have an output object as well. Now let's write a prompt object, and this is mostly a language agnostic structure. Okay, so in prompt, let's write translate the given statement into English language, and inside this I'm gonna pass here statement underscore to be translated or something like that. Okay, to be translated. This is basically the value that I have. Okay, statement to be translated, and now we'll have a prefix. So how do we define it? So complete JSON. It's not prefix. I think let me just check if there's anything. I think it's suffix. Yes, suffix, not prefix. Sorry. So complete JSON suffix, and I'm just gonna close my prompt, and let's close this prompt, and then RAIL. That's it. That's the structure. Let me just give you a walkthrough of the structure very quickly. Now what we're gonna doing here is we have a RAIL version, a script language, Python, and a register validator, and that which takes a name, a data type, which has a class which uses profanity check, passing a condition there, and then it says contains profanity language. Sorry, I can't respond, something like that. Okay, statement to be translated, complete JSON suffix, and we'll see it. Okay, now we have to use this. So let's use this. So what I'm going to do, I'm going to write a variable called guard, and in this guard I'm just going to use gd.guard, and basically the gd that we have imported, the guardrails.guard, and I'm going to pass, it's not a function, from RAIL string. So from RAIL string, and inside this I'm going to pass my RAIL structure. So RAIL structure. Okay, RAIL string, and this is okay. Now let's use this, guys. So what I'm going to do here, I'm going to write ht.info again here, translation response with guardrails, and I'm going to just use this function that we have defined on top. Let me just cut it, guys. Okay, not required. ht.info, and so let's use that thingy here. So let's write a variable called run LLM response, and inside this I'm just gonna use, okay, so we also run LLM response. Let me just see that function. Okay, return schema. Okay, we also need validation. So run LLM response and validated response. So you can also do validate. If you are doing it in terminal, you can track it down, run LLM response, validated response, and I'm just going to use guard, which has this variable, and inside this I'm going to pass my entire thingy here. So inside this guard, open AI dot, let me just use this code quickly, which I have written on top. Maybe we can beautify this code, guys. We can write the function separately. Okay, but maybe I'll just save some time, and let me know if you have done it in a different way. I think we can write this code separately as well. Okay, we don't have to write inside this. Excuse me. Control G. I just remove this engine here. I'm just gonna pass this engine over here. Okay, the engine, and that will be changed. Okay, let's handle that later. Max tokens, temperature, and this will be, let's use 0. What is this? This is okay. Temperature guard, text area. Now this looks nice. Okay, so what I'm gonna do here, I'm gonna also use, st dot. Let me just use st dot. Just use the write, guys. st dot write and see what we are getting. I don't know what kind of response we are getting, or let me just write f or something. st dot validated validated output. Or let me just see what we are getting. I will not write this. Okay, let's write validated response. Let's return that only and see what we are getting. So what I'm going to do here, I think we have to make these changes. This will not be text. This will be text area here, because that's what our input, and we don't need this entire thingy here. So what I'm going to do, I'm just going to remove this prompt from now, and I'm going to use, this will be, I think, excuse me, this will be inside this. Okay, and here we'll pass our statement to be translated. Statement to be translated. Statement to be translated, and this looks okay, and this will be plus text area. So let me just, and it's not text plus text area, just statement to be translated text area. Let me see. So we have a response, openai.completion.create. We have a prompt params. Let me just call this prompt params here. That's what the documentation says. Prompt params engine and text dimension max token temperature. I think we are good with this, but let's see if we are getting any error. We'll solve this. Okay, probably issue.write, this might give an error if it doesn't accept like this. So let's run this guy. Let me just see, come back here and do let me just copy this, and I'll just do a, it says name register validator is not defined. It says from string. So let's see that register validator. So I'll just come here on this register validator and register validator. Oh, that's strange. So we have register validator, script language Python, RAIL version, name is profanity check, and where do we use this register validator? This looks nice. Let me just debug this. So I fixed the error, guys. The main error was because we are importing this outside of this RAIL structure that we have specified, right? But we have a script language Python, so we have to import the dependencies that are required to run this, this RAIL, that reliable AI markup language. We have to import this within this structure. Okay, so right, what I did, I just imported the validator, event detail, and register validator, and the profanity check, the required dependencies within this structure, within this specification that we have. And now let's run this, and everything remains same. So what I'm going to do here, I'm just going to come back and I'm going to copy this, which is again kill yourself, and let's put that here. So when I click on translate, you can see it says translation without guardrails. That's basically the GPT-3 models, which will give you like commit suicide or kill suicide or something like that. Okay, so now let's see that. You can see commit suicide. Okay, now we're also looking at translation without with guardrails. Okay, with guardrails, and it says validated output translated statement nothing. So it returns nothing, but let's modify that a bit. So what I'm going to do here, let's see where the output is. You can see here, right? This string, the string literal that we have, there's nothing inside it. So let's write something like, sorry, I cannot, sorry, it contains profanity language, I cannot respond, I cannot return the result or something like this. So I cannot return the results. So we have now this, defined this. So when we run this again, click on translate. Now this time what it should do, probably, that it will give you this message. You can see here, validated output, sorry, it contains profanity language, I cannot return the result. So basically a profanity filter that we have put right through some guardrails mechanism that we have put in place, that will look at the language of that respond, if this needs some kind of moderation, or if there is any kind of filtering that it can do, from the profanity standpoint. And that's what we are doing here on this validation output. We are validating the output, which is extremely important to validate the response coming from a large language model. So let me just come here, and you can also change the setting from here to light and see how it looks. You can see it over here, right? Validated output, commit suicide, translation without guardrails, and translation with guardrails. Now this is just a boilerplate for you guys. Now you can bring more techniques here to basically write, like extend this that you see, right? This specification, the rail language that we have, the markup language, with the help of guardrails AI, the guardrails that are imported. You can bring a lot of other algorithms within this, and that you can look at, check. You can also look at if there's kind of any gibberish respond. You can also find out the gibberish respond. You can also, you're already doing profanity filtering. You can look at some wordings that you want to control. So there are a lot of other things that you can look at it to make your chatbot or the conversational system more aligned to your ethical guidelines. If you're working in your organization, they will have some kind of ethical guidelines. Now you can bring all those collective intelligence within this structure here, and you can run your application on top of it. But let's try one thing. Okay, I just got a message here, but it's okay. So let me just do one thing, guys. Quickly just change the setting to dark. And this is what I wanted to do in this video, but in the an upcoming video we'll create more such videos on guardrails, mainly with NVIDIA Nemo and all. So if you like this video, okay, please share your thoughts and feedback in the comment box, and please hit the like icon as well if you like the video. And if you haven't subscribed the channel yet, do subscribe the channel and share the video with your friends and to peers. The code will be available on GitHub. Please go ahead and extend the project, and let me know what you do with this code base and this library in the comment box. Thank you so much for watching. See you in the next one, guys.